Join me as I dive into Einstein's craziest theory and see if I can make sense of it all without losing my mind. Get ready to have your mind blown, because today we're talking about one of the most revolutionary ideas in the history of physics. It's a theory that turned our understanding of the universe on its head, and it's still blowing people's minds to this day. Before we dive in, it's worth noting that traditional views of physics before Einstein were pretty limited. They were built on a foundation of classical mechanics, which said that the laws of physics were absolute and unchanging. But this approach had some major flaws. It couldn't explain things like electromagnetic waves or the behavior of atoms and molecules. It was a narrow-minded view of the universe, and it was only a matter of time before someone came along and shook things up. Classical mechanics also relied heavily on the idea of absolute time and space. It was thought that time and space were fixed, unchanging constants that applied everywhere in the universe. But Einstein was about to show us that this wasn't the case at all. In fact, time and space are relative, and they can be affected by gravity and motion. Einstein's theory of relativity was a game-changer, and it's still one of the most mind-blowing concepts in all of physics. At its core, relativity is the idea that the laws of physics are the same everywhere in the universe, and that the passage of time and the length of objects can be different depending on your frame of reference. Sounds weird, right? But just stick with me, and I'll try to break it down in a way that makes sense. So, let's start with the concept of time dilation. This is the idea that time can appear to pass at different rates depending on your frame of reference. For example, imagine you're on a train, and you throw a ball straight up in the air. From your perspective on the train, the ball goes up and comes back down, and the whole thing takes a few seconds. But if you were to ask someone standing on the platform watching the train go by, they would say that the ball didn't just go straight up and down, it also moved really fast in the direction the train was moving. That's kind of like what happens with time dilation. If you're moving really fast, time can appear to pass more slowly for you compared to someone who is standing still. It's a pretty weird concept, but it's been proven time and time again in experiments. And it's not just a little effect, either. Under the right conditions, time dilation can add up to some serious differences in the way time passes. Another key aspect of relativity is the concept of length contraction. This is the idea that objects can appear shorter or longer depending on your frame of reference. For example, imagine you're on that same train, and you've got a ruler that's 10 feet long. From your perspective on the train, the ruler is still 10 feet long. But if you were to ask someone standing on the platform watching the train go by, they would say that the ruler looks shorter than 10 feet long because it's moving really fast in the direction the train is moving. So, what's the most mind-blowing aspect of Einstein's theory? For me, it's got to be the idea that time is not absolute. I mean, think about it, we're used to thinking of time as this fixed, linear thing that marches on relentlessly. But relativity shows us that time is relative, and it can be affected by gravity and motion. It's a pretty wild concept, and it's opened up all kinds of possibilities for our understanding of the universe. For example, imagine you've got two twins, and one of them gets on a spaceship and travels to a distant star and back. Let's say the trip takes 10 years from the perspective of the twin on the spaceship. But when they get back to Earth, they might find that their twin has aged 20 years, because time passed more slowly for them on the spaceship due to time dilation. It's a real-world example of relativity in action, and it's pretty amazing. So, to recap, we've talked about how Einstein's theory of relativity revolutionized our understanding of the universe by showing us that time and space are relative, and can be affected by gravity and motion. We've delved into the details of relativity, including time dilation and length contraction. And we've seen how relativity has opened up all kinds of possibilities for our understanding of the universe. Thanks for joining me on this journey into the wild world of Einstein's theory of relativity. If you've got thoughts or questions, be sure to leave them in the comments below, and if you want to learn more about scientific theories and discoveries, be sure to check out our next video.